Later on, when we subnet IP addresses, you will see some interesting scenarios like 192.168.9.70 using a subnet mask of 255.255.255.192. And you might sit there and wonder, well, what the heck is that? Well, we know 255 is covering 192, and we know this 255 is covering all 8 bits in the second octet, so it's covering 168, and this 255 is covering all the bits in the third octet, so it's covering 9. This 192 is some ones and some zeros, so it's therefore covering some of the bits in the fourth octet. So part of this 70 is covered and the other part is not covered. Now, this confuses most of my students when I say that, but that's basically what's happening. And to see this, we have to look at 70 in binary. So whenever you're confronted with a scenario like this, the first process to make your life easy is to look at which octets are covered entirely, and that would be the first 3 octets. And then in the octet that is being partially covered, take the IP address number in there, which is 70 in this case, convert that to binary, and we will do the same thing for the number that is in the subnet mask. 70 in binary is 0, 1, 1, 0, 0, 0, 1, 0. Now, if you used a calculator to do this conversion, it would not give you this 0 because this is a leading 0 and leading zeros have no value. Therefore, a calculator would not show it to you. It is immensely important that if you use a calculator to convert decimal to binary, you check the number of bits it gave you, and if it gave you 7 bits, you put a 0 in the front here to make up 8 bits, because in this octet you have 8 bits. This 0, if omitted, changes everything. And you'll see what I mean. Let's take 192 and convert it to binary. 192 in binary, this is something we did earlier, is 1, 1 and 6, 5, 6 zeros. So these 2 ones in this subnet mask are like pickets in a fence that's covering these 2 bits. If you had omitted this first 0, then you might have mistakenly covered these 2 bits, which would have been wrong. This is why you need to remember to ensure that if you use a calculator and it gives you 6 bits, you put 2 zeros in front. If it gives you 7 bits, you put 1 0 in front. Make sure you make up your 8 bits. So these 2 ones in this fence, again, try to see a fence, and these are pickets in the fence. It's covering these 2 bits. Whatever the value is of these 2 bits, that is network ID, and the remaining bits here are left uncovered. This is host ID. So this first column here is 128, and this column here is 64. So therefore, the network ID here, the value of these network bits, is 64. The value of this column is 2, and this is 4. 4 plus 2 is 6. Host ID is therefore 6. So this 70 has been split into 64 as your network ID, and 6 is your host ID. Let me write this more clearly. So the IP address once again was 192.168.9.70. Your subnet mask was 255.255.255.192. My network ID is 192.168.9. Let me just flip back here. These first two bits in this last octet are being covered by these first two ones here in 192. The value of these two bits, 0, 1, is 64. So my network ID is 9.64. The host ID are the bits that are left uncovered. Coming back here, that would be these 6 bits which carry a value of 6. Because this is 1, the others are 0. So flipping back here, my host ID is .6. And if you added the host ID to the network ID, you should always get back your IP address. If you do that addition and you don't get back your IP address, you made a calculation error somewhere. So 64 plus 6 is 70. We get back our original IP address. This computation is correct.